Hello, welcome back to BLENDERSUSHI Live Noding. In this episode, we're gonna learn to try to create this kind of pattern. Can you guess what it is? This is actually just an eye illusion. It's not like a bunch of 3D boxes rotated. They are actually just like a flat objects. I'm looking at it from the top, and this guy actually can give us like kind of unlimited kind of design pattern. I'll reduce it and I'll show you like a different kind of pattern that we can have with this guy, and we can also randomize the seed. We have unlimited variation of colors as well because of the noise, and this guy is actually based on a circle, believe it or not. So if I try to increase the number of points, you will see, okay, this guy is basically just a circle and it's being subdivided depending on this number. And I'm using the monad, kind of the monad grouping in Sverchok, and by doing that I'm being able to kind of turn it into like multiple instances and arrange it in the grid. So inside the monad itself we have just a bunch of nodes that actually generates this guy. If I reduce it to 2 by 2 and we have this, but I kind of like this guy. It looks like a 3D cube. If you are actually interested to do this using 3D objects in Blender, you can also easily do that. If I'm gonna show you real quick. Where is it? Honeycomb, circular pattern, box hexagonal. There you go. This is kind of same kind of ideas, but this is actually, if you look at it from the top orthographically, this guy is actually real 3D, and I don't know which one is more interesting, the cube or actually the flat one. With the cube, of course, you can kind of move around point light and then they're gonna change. And even here I'm kind of having it so they are rotating randomly, so they are more random, but they are actually just 3D cube. I challenge you to make this as well, but we're gonna do the other one from scratch. Okay, so file, save as, Sverchok, how should I call it, eye illusion 3D cube flat. I'll just call it a flat 3D cube, and then switch on Sverchok, and let's get started. View top. So the idea is, of course, to have like just a slice of pie and divide it into at least 3. So we can use circle, we will draw, and by default circle looks like this, nothing too fancy, and we can change the vertices, etc. But there is this different mode of circle that's allowing us to turn this guy into slices of pie, something like this. So this is really convenient for us, so we can easily make like a pie chart if we want. So let's use this guy and just use the bare minimum of the points. I wish this guy can go even lower than this. 3 vertices should go to 2 so we can have like triangles, but I guess this is okay. And let's have it like 30 degrees for what we are doing, and I'm gonna try to plug in transformation matrix and try to make duplicates. This is how I did it. There's probably like a better, more elegant way to do this. There's always another way to do this. Angle, for the angle, I think I can use range float, and start stop maybe 360. Oops, actually that's a lot too much. Okay, 360 is correct, but we need to care about the count. So for 30 degree, we seem to need a 13 here. Let's try 60 degree. Maybe we're gonna have like 6. Oh, apparently we need to have 7. But that's kind of incorrect, because if we bake it, we're gonna have like 1, 2. Let me turn off that guy. 3. Okay, we have, apparently we have 7 pieces, and it's kind of doubling in this guy. So we don't want that. My trick is just to use a least slice and just get rid of the last one. Start stop level 1. I think, let me show it. Least slice level 2 seems to be wrong. Level 1. Okay, level 1. And slice this guy. Maybe level 0. Apparently we just need level 0, and then we have start stop 1, 2, 3, 4, 5, 6, 7. We don't need number 7. We actually stop at index number 6. So knowing that, we can just plug this guy in like this. 6, and this should be 6 plus 1. 6 plus 1. I'm trying to think of this parameter that's controlling the pi, and this number 6 can also be used for this guy, degree. So math, this should be divided by 360 divided by 6 is 60. Plug into this guy, and the vertices controlling the resolution of the circle itself, so it doesn't matter too much. The radius is free. Okay, so we have it. This is the thing. If we bake it, we have our pi, and we can easily separate the pi. It's being basically it's a circle that's being divided by this number 6. So we have 6 pi. If we give it a number 3, we only have 3. And this is of course still looking like a pi, but if we reduce this, we actually have this fake 3D cube. Okay, cool. We are kind of almost there, almost done, but I want to do a little bit more. I want to give this color, and for that I will try to join them. First of all, we're gonna use a BMesh viewer. So instead of having to do the baking, I want to be able to just output this object as a real object. So I'm gonna use matrix apply and plug into this guy, and then we're gonna need to use the polygon. I think this is already working, even though there is some kind of a smart thing that's happening here. That's kind of automatic if you use viewer BMesh. But if you try to cut this and plug this guy into that guy and then polygon directly, normally it will not work. You see, it's not working properly. You kind of need to use a list repeat, and that number should correspond to this guy. Unwrap as well. So bake. Now it's looking almost correct. Let me try again. bake. 1, 2, 3. Okay, cool. So that's what we're gonna use here as well. Hide this and then refresh, and we have this. So they are still like a separate objects. You can have it that way, but I want it to be a single object instead of alpha 0, 1, 2. See, if we are kind of increasing this number, we're gonna get more objects. I don't want that. I just want it to be a single mesh, so I'm gonna use mesh join, and vertices goes into here, polygon, and then that's the final result. Single objects. They are, I believe, they are still actually separate inside, but they are at least a single object. And with the single objects, we have convenience of being able to apply a vertex color. So that's gonna be the next bit. Vertex color, vertex color new. Okay, that's the nodes. We're gonna switch to cycles, and with the cycles, I'll create a new material, and then I'm gonna use it here. So material .001, and for this material, we're gonna assign a vertex color. It's by default, it's called SV col. I'll try with random color first of all. Random vector, just plug into this guy. How many count? 3, because, and we're gonna colorize the face. Okay, so is this already working? Let's have a look. We have SV goal. Switch to material and check it out. Using attribute nodes, we can just plug in SV col. Color goes into this guy, and cool. You see, in a Blender, this is the latest Blender 2.78b. In this version, Blender cycle is a lot faster, and then also you can see the preview of vertex color. So this is really handy. You don't need to switch to vertex painting and to be able to see this color anymore. You just stay in object mode, and then it will update itself. Cool. All right. You can see this is actually working. With random vector, of course, sometimes you get a black because it's minus. If you check the number here, minus, so we don't want that. Vector out and vector in with absolute, and that should take care of our negative value. 1, 2, 3. Plug into this guy, and we have random color for our fake cube. So they look like a 3D cube, but they're actually just fake, of course. Randomize the seed. There you go. That you have it. This is how you can create this fake 3D cube. It's a flat 3D. You can use this to also generate like a pie chart. Currently, the pie chart only have like 3 colors, so I will plug this guy also to the count. There you go. That's really nice actually. You can use this for other kind of design project. For now, just a cube. What else can we do here? Instead of random color, you can also assign noise, of course, but vector noise expecting vertices here. You can use line. I guess just do it like this. Put the count into the line, vertices into this guy, and the noise into this guy. This is standard Perlin, Voronoi, there's one Voronoi, I think F4, that's giving you kind of nice pastel color. F3 also. Yeah, that's very nice, interesting looking design. 3, okay. Let's limit this guy into 3, maximum 100. So there you go. Fairly easy, simple to do. Of course, if you want, you can turn this into a monet, like what I did in the example. For the monet part, I'll leave it to you. It's up to you how you want to do it. It's a homework if you want to do it. But yeah, you kind of get the idea how you can create this guy. It's rather simple once you understand. You get the drill. That's the Voronoi scalar standard pooling. Yeah, so that's gonna look like a fake 3D from the top. With my example, of course, I have the monad, so I'm being able to replicate this guy and then kind of rotate it 60 degree or 120 degree. It's actually more like 90 degree. So you have you can have 3 variations of the same fake 3D cube. Okay, so that's pretty much it for this live noding video. Hopefully you find this interesting and useful. Let me know in the comments below if you have any feedback, suggestion, or any question. Thanks again for tuning in, and I'll see you in the next video.